In this video, we are going to discuss about Euclid's division lemma and division algorithm to find HCF of two numbers. Okay, ఈ వీడియో చివరి వరకు చూడండి so that you will understand the concept well. Let us now learn about Euclid's division lemma. Euclid's division lemma ఏమని చెప్తుందంటే for a given pair of integers a and b, we can find unique integers q and r such that a is equal to b times q plus r, where r is less than b and greater than 0 or equal to 0. అర్థమైందా? ఏమని చెప్తుంది? a and b అనే టూ ఇంటీజర్స్ ఉంటే కనుక we can find two more integers q and r such that a is equal to b times q plus r, okay, where r is less than b and greater than or equal to 0 అని చెప్తుంది. Let us consider few examples to understand this well. a equal to 19 and b equal to 2 అనే ఒక ఎగ్జాంపుల్ తీసుకున్నాం అనుకోండి. a equal to b times q plus r అని ఉంది, రైట్? We know that dividend equal to divisor times quotient plus remainder. ఓకే, a అనేది కనుక డివిడెండ్ అయితే b is divisor, q is quotient and r is remainder, right? So now a is dividend and b is divisor, meaning we have to divide 19 with number 2. 9 times 2, 18. When you subtract, you are getting 1 as the remainder. Now, we can write in this format, right? It means a, that is equal to 19, equal to b, that is 2, times q, quotient anta 9 plus 1. Okay? Euclid's division lemma use cheste, we are going to get this. Or simply, you can use this division thing so that you can get an expression like this, an equation like this, right? Let's look at another example. a equal to 19 and b equal to 3. It means dividend is 19 and divisor is 3. Let's divide 19 with 3. 6 times 3 is 18. When you subtract, you have 1. It means 19 equal to 3 into 6 plus 1, right? Let us consider another example. 19 and 4. Let's divide number 19 with 4. 4 times 4 is 16. When you subtract, you are getting remainder is 3. It means 19 equal to 4 into 4 plus 3. Let's take another example, that is 19 and 1. I can write this as 19 equal to 1 into 19 plus 0. You observe this. Divisor 2 ఉన్నప్పుడు remainder 1 ఉంది. Divisor 3 ఉన్నప్పుడు remainder 1. Divisor 4 ఉన్నప్పుడు remainder 3. Divisor 1 ఉన్నప్పుడు remainder 0. Right? If you look at, the remainders are always smaller than divisors. You see, r is always smaller than divisor and sometimes it is equal to 0. In particular case lo chuste, that is equal to 0. This is exactly what Euclid's division lemma is saying, that, right? It is saying that a and b are two integers. If you have, then we can find two more integers q and r, okay, where r is less than b, okay, r is less than b, and at the same time r can be any number between 0 to b, or it can be 0 also. This is what exactly Euclid's division lemma is saying. Okay, understood? Let us now learn about division algorithm to find HCF. మనకి two numbers ఇస్తే కనుక, if you are asked to find what is the highest common factor of those two numbers, we can use division algorithm to find HCF. డివిజన్ అల్గారిథం కొన్నిసార్లు యూక్లిడ్స్ డివిజన్ అల్గారిథం అంటారు, కొన్నిసార్లు యూక్లిడ్స్ అల్గారిథం అని కూడా అంటారు. ఓకే, ఇన్ దిస్ అల్గారిథం వాట్ వీఆర్ గోయింగ్ టు డూ ఇస్ వీఆర్ గోయింగ్ టు అప్లై ద డివిజన్ లెమ్మా మల్టిపుల్ టైమ్స్ టు సెట్ ఆఫ్ నెంబర్స్. అది ఎలాగో చూద్దాం. ఫర్ ఎగ్జాంపుల్, ఇఫ్ ఐ హ్యావ్ టూ నెంబర్స్ సి అండ్ డి, వేర్ సి ఈజ్ గ్రేటర్ దాన్ డి, and I want to find HCF of these two numbers, then I can apply the division lemma to these two numbers. Division lemma apply cheyali ante, can you recall what is the division lemma? The division lemma says that if there are two numbers A and B, we can find two unique integers Q and R such that A can be written as B times Q plus R, where R is less than B, at the same time R is greater than or equal to 0. Right? R anedi, it is going to be in between 0 and B, and sometimes it can be equal to 0 also. So, in particular case lo, if I want to apply the division lemma, this is going to be my dividend and this is going to be my divisor. Enduku? D అనేది స్మాలర్ నెంబర్ కాబట్టి ఇది డివైజర్ అవుతుంది. సో యాజ్ పర్ ద డివిజన్ లెమ్మా, నౌ ఐ కెన్ రైట్ C ఈక్వల్ టు D టైమ్స్ సమ్ కోఎఫిషియంట్ Q1 ప్లస్ రిమైండర్ R1. ఓకే, అండ్ వీ నో దట్ యాజ్ పర్ ద డివిజన్ లెమ్మా R1, the remainder R1 is smaller than divisor D. ఈ పర్టికులర్ కేసులో smaller than B, right? ఈ particular case లో smaller than D. Now we have to see whether the remainder is equal to 0 or not. If the remainder R1 equal to 0, then the division algorithm says that the divisor D is going to be the HCF. Please note this. ఎప్పుడైతే రిమైండర్ 0 అయిందో, డివైజర్ ఏదైతే ఉందో ఆ పర్టికులర్ స్టెప్లో, that is going to be the HCF of the originally given numbers. అర్థమైందా? ఇన్ కేస్ రిమైండర్ R1 అనేది 0 అవ్వలేదు అనుకుందాం, we have to apply the division lemma again to the numbers D and R1. You see ఇక్కడ D and R1 ఉన్నాయి కదా, వాటికి డివిజన్ లెమ్మా అగైన్ వీ హ్యావ్ టు అప్లై. అంటే అప్పుడు ఏమని రాయొచ్చు, ద డివిడెండ్ D ఈ పర్టికులర్ కేసులో R1 is smaller than D, right? Or D is greater than R1. ఈ పర్టికులర్ కేసులో C is greater than D. అందు గురించి C అనేది డివిడెండ్ అయింది, ఇక్కడ D అనేది డివిడెండ్ అవుతుంది, రైట్? నౌ ఐ కెన్ రైట్ దిస్ యాజ్ డివిడెండ్ D ఈక్వల్ టు డివైజర్ R1 times coefficient, that is I am denoting it as Q2 plus remainder R2. I can write like this, right? Now if you look at this R2, remainder R2 has to be less than R1. Please note this. That is what the division lemma is saying, right? Now again check whether the remainder R2 is 0 or not. If it is not 0, we have to repeat this step till the remainder goes to 0. Okay? Now divisional lemma A, for example, R2 is not equal to 0. అప్పుడు డివిజన్ లెమ్మా వేటికి అప్లై చేయాలి, R1 అండ్ R2కి అప్లై చేయాలి. అర్థమైందా? Now let's look at one example problem. Find HCF of two numbers 900 and 270 using Euclid's division algorithm. Division algorithm first step ఏమని చెప్తుంది, to find HCF of two numbers C and D, we have to apply division lemma to those two numbers and see what is the remainder, right? If remainder is 0, then the divisor is going to be the HCF. If remainder is not equal to 0, we have to apply the division lemma to the divisor and remainder. And we have to continue this process till the remainder goes to 0. Right? So let's start with this. మన దగ్గర two numbers ఉన్నాయి, 900 and 270. 900 is greater than 270. Right? అంటే This is going to be my dividend and this is going to be divisor, right? Let's apply division lemma to these two numbers. Now let me divide 900 with 270. 3 times 270 is 810, right? When you subtract, what we are getting, 90 as the remainder, right? Now I can write dividend 900 equal to divisor 270 into quotient 3 plus remainder 90. Remainder 90 kada? Remainder is not equal to 0, right? It means we have to apply the division lemma now to the divisor, that is 270 in this case, and remainder, that is 90 in this case, right? We have to apply division lemma now to 270 and 90. Let's divide 270 now with 90. 3 times 90 is 270, right? When you subtract, what you have, 0 as the remainder. It means I can write 270 equal to 90 into 3 plus 0. Remainder is 0. Remainder is 0 అయితే divisor is the HCF, right? ఈ particular case లో divisor is 90, right? It means the HCF of these two numbers is 90. Highest common factor of 270 and 900 is 90. Understood? ఈ మెథడ్ కాకుండా if you want to use prime factorization method to find, then it is a laborious process, right? Prime factorization method యూస్ చేసి కూడా రాయొచ్చు. You can find HCF of these two numbers. కానీ అది బాగా లెందీ. But this is 2 steps లో you are done, right? Let us now look at another problem, that is find HCF of two numbers 300 and 550 using Euclid's division algorithm. Okay? Division algorithm lo first step enti, we have to apply division lemma to the given number, right? Let's apply division lemma to 300 and 550. 550 is the bigger number, so it's going to be our dividend. So we have to divide 550 with 300, right? 1 times. So when you subtract 300 from 550, what you have, 250 as the remainder, right? So division lemma em ani cheptundi, 550 is equal to 300 times quotient, that is 1, plus remainder 250. Remainder is not equal to 0, right? It means we have to apply division lemma now to the divisor and remainder. In particular case lo divisor is 300 and remainder is 250, right? Now we have to apply division lemma to these two numbers 300 and 250. Let me divide 300 now with 250. 1 times 250. When you subtract, then what you have, 50 as the remainder, right? Again, I can write 300 equal to 250 into 1 plus 50. Remainder is not equal to 0, right? It means we have to apply again the division lemma to 50 and 250. These are the two numbers. We have to apply division lemma now. 250 and 50. 250 అనేది bigger number కాబట్టి you divide now 250 with the number 50. 5 times 50 is 250. When you subtract, you have 0 as the remainder, right? Now I can write this as 250, that is dividend, equal to divisor 50 times quotient 5 plus remainder 0, right? Look at this, remainder is 0 and divisor is 50, right? మనకి ఎప్పుడైతే రిమైండర్ is 0 అయితే divisor is going to be the HCF. అంటే 300 and 550 అనే 2 నెంబర్స్కి HCF ఏంటి, 50. Let's write that. Highest common factor of these two numbers 300 and 550 is number 50. Understood? Division algorithm ఏం చెప్తుంది, you have to apply division lemma multiple times till you get the remainder equal to 0. ఎప్పుడైతే రిమైండర్ 0 అయిపోయిందో, you say that the divisor is going to be the HCF of given numbers. Understood?